Hello everyone, this is Martz, and today we are going to continue with a exercise that we did in another video. This is an structure that is for use as a crane with a hoist on the center. So here what we're going to do is to do the analysis. I used to do the analysis here because the frame analysis tool, it is a light uh, version of an FEA, and we don't need really to do details like weldings or bolt connections and all that. So you can do on a first state, after you do your skeleton and place the elements that you think that are going to work, you can double check the design and make that decision to change the elements and all that depending on the results of the analysis. So by starting on the same tab of the design, where the frame generator, you can find this analysis. So first thing is to create a simulation. The first option is to do a static analysis or a model analysis. I'm going to talk a little bit more model in another video, but now we are going to talk about static analysis. You can rename the simulation if you want, and if you have representations, positions, and level of details already created on the model, you can use them. But in this case, this is really simple, so not necessary. So as you can see, Inventor is creating like the same skeleton that we did for create the structure, but in this case the elements has a connection between them. Those elements have a connection between them with something called rigid links, and it is placed automatically. Inventor recognizes the elements, but it only recognizes frame generator elements. If you did the sketch of the beam and did the extrusion, it is not going to work. So that's basically because Inventor cannot understand that it is a frame element, and it cannot extract the information, the valuable information that we have for doing from a frame analysis, which is not only about to have the standards and all that. It is more. It goes more on deep on this. Okay, so for start, as usual on FEA, we have in order from left to right the tools that we are going to need. So the first thing that we are going to see is the properties. In this case, for example, you can see that here appears the elements, and well, if you check the video about the creation of this model, we did most of these components with the reuse tool, and if we do it in the other way, that just picking the different elements, we're going to see here a more extended list and maybe a little bit more complex to read, but in this case it is not, because we are reusing all the elements. So it is as simple as I have just these elements. Okay, so if you go picking each component, each beam, it is going to be highlighted on red on the graphic area. You're going to see the inertial moment, the moment of inertia. and other uh, information about the beam that Inventor can read because it is a frame generator model, right? So then we have the material, of course. Actually, we have steel for all them. If you want to change it, you need to go to the frame generator uh, model and change the material when you are editing the element. By the moment, we don't have in this version 2018 the option for override in this kind of analysis, uh, as well as on regular FEA. Okay. So then we have the fix. We have several types. I'm going to fix this guy here. Check that the direction of my fix is like in the way how the gravity is right now. So this is not definitely the behavior of what I'm looking as my gravity. So I'm going to modify it, and I'm going to select the C direction and use the standard magnitude for gravity. Okay, so I'm going to go to the constraints options, and I'm going to delete this guy. I'm going to create a new one, and it is oriented as I want. Okay, since I'm pretending to have some bolts here on these plates, I would like to do a fixed constraint on each node of these elements. Okay, so I'm going to use fixed right here. Unfortunately, every time we want to fix an element, we're going to need to do this. But well, that's one way. You can also, for simplifications, you can just choose to select this point. I'm going to do it in that way for go faster. In any ways, for have a more precise behavior or result about this small element, we can do later an FEA with mesh and all that. So I'm going to just do the fix right here, always placing it on the plate. I don't want to touch the node of the beam. All right. Would be great to have to have the chance to place all these elements without going every single time to pick the fixed constraint tool, but it's okay. There we go. Okay, so there are other types of constraints, for example pin, floating, and some customs that you can select exactly the degrees of freedom of your constraint. Then we have force and continuous load. So I'm going to, in this case, select a force, a punctual force. We can place it based on the reference, on the distance. We can change the direction, in this case the angle, and this other angle. I'm going to keep it as it is right now. And by double clicking we can see the values. So we can choose here a magnitude. Let's say that it is going to be this one. This angle that doesn't matter, so it can be 0 as well, 180 degrees, and the offset is this one. We have also the option for place the vectors and all that. And about the offset, if you don't know the length of this element, to be honest, I don't. So you can select the option for the offset as relative. So I want it in the center, just type 0.5 and that's it. Okay, so we have the gravity and we have the force. I'm going to save this. And well, we can also add a moment, and well, the continuous load, which is very cool tool. I really like it, but in this exercise we're not going to talk much about it. Okay, so we can now jump directly to simulate. Let's give a chance. It is really fast, and that's something that I really like, because you don't need to wait, for example, for generating the mesh and calculating and do several passes, doing the redefinement of the meshing and all that. So of course it is going to give the same kind of the same results. They're very close between each other, but ones need more time, and this one is perfect for have the model that you want without wasting too much time on analysis. So you can, on a fast way, on the first step of the design, have the correct elements for your model. So talking about the results, we have several of them. The first one is the displacement. We don't have much displacement here, which is cool. Unfortunately,